Now, starting with the numericals of electricity chapter, the first numerical, that is example 11.1, says a current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes, and the amount of electric charge that flows through the circuit. So, here I equal to 0.5 ampere is given, Q is not given to me, so T is given as 10 minutes, but I can't take it in minutes, I have to convert it into second. So 10 into 60 second, as 1 minute equal to 60 seconds, so this will be 600 seconds. So now the formula is I equal to Q by T. So using that formula I want to find Q, so I will do I into T. So that will be 0.5 into 600. So that will come to 300 coulomb. So charge is 300 coulomb. Now example 11.2 says how much work is done in moving a charge of 2 coulomb across 2 points having a potential difference of 12 volt. Here work W equal to question mark, charge that is Q equal to 2C, and V equal to 12 volt, that is potential difference. So we know that V equal to W by Q. So from that W will be equal to QV. So that is 12 into 2, so that will be 24. So I got the work done as 24. Now example 11.3 says how much current will an electric bulb draw from a 220 volt source if the resistance of the bulb filament is 1200 ohms. B part. How much current will an electric heater coil draw from a 220 volt source if the resistance of the heater coil is 100 ohm? So here if I see carefully, I am given V equal to 220 volt. I don't know, current I have to find, and R is given in the first one 1200 ohms. So the formula used will be V equal to IR. So I equal to V by R. So that will be 220 upon 1200. So that will come to 11 upon 60, and that will be 0.18 ampere. So I ampere. Now moving ahead in the B part, it is said V equal to 220 volt, R is 100 ohm. So again I equal to V by R. So that will be volt is 220 upon O, resistance is 100. So this will directly come to 2.2 ampere. So I got both the answers. Now 11.4 example says the potential difference between the terminals of an electric heater is 60 watt when it draws a current of 4 ampere from the source. What current will the heater draw if the potential difference is increased to 120 watt? So first V equal to 60 volt and I is 4 ampere. So let us find the resistance. So V will be IR. So 60 equal to 4 into R. So R will be 60 by 4, that is 15 ohm. Now in the next case V is IR and 120 volt is the given thing. When 120 volt will be there, what will be the current? So equal to I into resistance will be 15 ohms. So I equal to 120 upon 15. So that will be 8 ampere. So I will be 8 ampere. Now, example even 11.5 says resistance of a metal wire of length 1 meter is 26 ohms at 20 degree. If the diameter of the wire is 0.3 mm, what will be the resistivity of the metal at that temperature? Using table 11.2, predict the material of wire. So here length equal to 1 meter wire and R equal to 26 ohms. Then diameter equal to 0.3 mm. So if I convert it into meter, it will be 0.3 into 1 upon 1000 meter. So that is 3 into 10 raised to minus 4 meter. Now the formula of resistance R equal to resistivity L upon A. So here A equal to pi R square. So resistivity equal to RA upon L. So that I can say in place of R I am writing 26. Then pi I am taking as 3.14 into R is 3 into 10 raised to minus 4 upon 2 whole square. So that is coming as 26 into 3.14 into 3 into 10 raised to minus 4 into 3 into 10 raised to minus 4 whole upon 2 into 2. So if I cancel that out, I am getting 13 into 1.57 into 3 into 3 into 10 raised to minus 8. How I did? See, 13s are, this 2 ones are 1.57. So this is coming finally to 183.69 into 10 raised to minus 8. Now, seeing this from the table, I can say the material is manganese. Now example 11.6 says a wire of given material having length L and area of cross section A has a resistance of 4 ohm. What would be the resistance of another wire of the same material having length L by 2 and a area of cross section 2A? So here length is, in the first K I am given length is L and R is 4 ohms. And area of cross section is A. So R equal to resistivity L upon A. So resistivity of L upon A will be 4. Because it is already given resistance is 4. So I am taking that as one equation. Now for wire 2, length is L by 2. Area of cross section A equal to 2A. And R I have to find. So there R will be equal to resistivity L upon 2 into 2A. That L upon 2 I have written L upon 2 upon 2A. So that will be resistivity of L upon 4A. So now if I take 1 upon 4 common outside, I will have L upon A. So now using equation 1, I can say this will be equal to 1 upon 4 into 4 using 1, equation 1. So this will be 1 ohms. Now 11.7 says an electric lamp whose resistance is 20 ohm and a conductor of 4 ohm resistance are connected to a 6 watt battery. See the figure. Calculate the total resistance of the circuit, then the current in the circuit and the total difference across the electric lamp and conductor. So here resistance of bulb is 20 ohm and resistance of resistor, that is RC, equal to 4 ohm. So V is 6 volt. So if I see they are connected in series, so RT, that is resistance, total resistance will be RB plus RC. So that will be 20 plus 4. So that will be 24 ohm. Now I equal to V upon R. So V is 6 upon 24. So that is 1 by 4. So that will be 0.25 ampere. So I got. Now I have to find V. So V equal to IR. So 0.25 into resistance of bulb. So that will be 0.25 into 20. So voltage will be 5 volt. Then the same way, if I find V equal to R IRC, so here 0.25 into 4, so that will be 1.00 volt. So both the potential difference I got. Now next question is first one at page 185. Draw a diagram of a circuit consisting of a battery of 3 cells of 2 volt each, a 5 ampere resistor, a 8 ohm resistor and a 12 ohm resistor, and a plug key, all connected in series. So first they are given in series, so I will have 3 resistances of different ohms resistance. So they are connected with 3 cells of battery. So this is one cell, this is second cell, this is third cell. Now a key. So this will be my diagram. Now this is 5 ohm, this is 8 ohm, this is 12 ohm, this is power key K, then this will be plus, this will be minus, and 2 volt 3 cells are there, so total voltage will be 6. Now question 2 says redraw the circuit of question 1 putting an ammeter to measure the current through the resistors and a voltmeter to measure the potential difference across the 12 ampere resistor. What would be the reading in the ammeter and the voltmeter? So if I draw the diagram again, so these are the 3 resistors and I have to attach a voltmeter in the parallel with 12 volts. So this is my voltmeter attached in parallel with 12 ohm resistor. This is 8 ohm, this is 5 ohm, and one ammeter they have told, so I am attaching the ammeter here. And now the circuit, the 3 cells of 2 and a key. So this will be my diagram. Now I am given I don't know, RT, that is total resistance will be 5 plus 8 plus 12, so that will be 25. Now V equal to IRT. So volt is 6, I don't know, and resistance is 25. So I will be 6 upon 25. So that will come to 0.24 ampere. Now we know that V equal to IR is the formula. So now I is 6 upon 25 and I am making the 12 volt resistance. So that will be 12 into 0.24. So that will be 2.88 volt. Now it is given in the circuit diagram given in figure. Suppose the resistors R1, R2 and R3 have the values 5 ohm, 10 ohm, 30 ohm respectively, which have been connected to a battery of 12 volt. Calculate the current through each resistor, the total current in the circuit and the total circuit resistance. So first let us find current through each resistor. So R1 equal to 5 ohm, R2 equal to 10 ohm and R3 ohm. So V equal to 12 volt. So first V equal to IR. So 12 equal to I1 into 5. So I1 will be 12 upon 5. So that is 2.4 ampere. Now moving ahead to find I2. Now V equal to I2R. So 12 equal to I2 into 10. So therefore I2 will be 12 upon 10, that is 1.2 ampere. And same way V equal to I3R. So 12 equal to 30 into I3. So therefore I3 equal to 12 upon 30. So that is coming to 0.4 ampere. Now B part was total current. So total current, let me call it as IT, equal to 2.4 plus 1.2 plus 0.4. So that will come to 4.0 ampere. Now C1 he is asking total resistance. So total resistance, as they are in parallel, so 1 upon RT will be equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So now putting the values in that, so this will be 1 upon 5 plus 1 upon 10 plus 1 upon 30, doing LCM as 30. So 6 plus 3 plus 1, so that is coming as 10 upon 30, so which is equal to 1 by 3. So 1 upon RT came as 1 upon 3. So therefore RT equal to 3 ohms. Now example even 11.9 says in figure 11.12 R1 equal to 10 ohm, R2 equal to 40 ohm, R3 equal to 30 ohm, R4 equal to 20 ohm and R5 equal to 60 ohm, and a 12 volt battery is connected to the arrangement. Calculate the total resistance in the circuit and the total current flowing in the circuit. So let us find first, write all the things which are given. R1 is 10 ohm, R2 is given as 40 ohm, R3 equal to 30 ohm, R4 is 20 ohm, R5 is 60 ohm and voltage is 12 volt. So now, so first I am finding 1 upon Rp1, that is the first parallel part, that is 1 upon R1 plus 1 upon R2. So that is 1 upon 10 plus 1 upon 40. So if I do the LCM as 40, this will be 4 plus 1, that is 5 upon 40, so equal to 1 upon 8. So therefore Rp1 equal to 8 ohm came. Now the second one is 1 upon Rp2 equal to 1 upon R3 plus 1 upon R4 plus 1 upon R5. So if I put the values, that is 1 upon 30 plus 1 upon 20 plus 1 upon 60. So LCM will be 60. So 2 plus 3 plus 1. So that is coming 6 upon 60. So that will be 1 upon 10 ohms. So therefore Rp2 is 10 ohms. Now he has asked me the total resistance in the circuit. So the total resistance RT will be RP1 plus RP2. So that is 8 plus 10. So that will be 18 ohms. And then B part he has asked me current I equal to V equal to 12 volt and R equal to total resistance is 18 volt. So we know that V equal to IR is the formula. So V is 12, I don't know, into R is 18. So I will be 12 upon 18. So that will come as 0.6 ampere. Now, example 11.10 says an electric iron consumes energy at a rate of 840 watt when heating is at the maximum rate and 360 watt when the heating is at the minimum. The voltage is 220. What are the current and the resistance in each case? See, here we know P is having two values, that is 840 volt and P equal to 360 watt when minimum 360 and when maximum 840, and V is given as 220 volt. So we know that P equal to VI. So in both the cases I am counting separately. So 840 equal to 220 into I. So I will be 840 upon 220. So that is coming as 3.8 ampere. So therefore here I will be 3.8 ampere. Now counting for the minimum one, so P equal to VI. So again 360 equal to 220 into I. So I will be equal to 360 upon 220. So that will be 1.6 ampere. So I got both the I 1.6 ampere and 3.8 ampere. So first part I have completed. Now he has said what are the current and the resistance. So to find the resistance, now see, again I am using V equal to IR formula. V equal to IR formula, and here voltage is 220, I is 3.8 and R I have to find. So R will be 220 upon 3.8. So that is coming as 57.89 ohm. So resistance is 57.89 in this case. And for the minimum one, V equal to IR again. So 220 equal to, that was 1.6 into R. So R will be 220 upon 1.6. So that is R equal to 137.5 ohms. So these are the two resistance required. Now question 11.11 says 100 joule of heat is produced each second in a 4 ohm resistor. Find the potential difference across the resistor. So here H is given as 100 joule, T is 1 second, R is 4 ohm and V is unknown. So I know that H equal to I square RT. So 100 equal to I square into 4 into 1. So I square will be 100 upon 4, that is 25. So I will be square root of 25. So that is 5 ampere. Now I got I. Now I have to find V. So V equal to IR. So that will be 5 into 4. So V is 20 watt. Now next question 2 on page 190 says compute the heat generated while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volt. So here H is given to me as unknown thing to be found. Q is 96,000 coulomb. Then T equal to 1 hour, that will be 3600 seconds, and V equal to 50 volt. Now I know that I equal to Q by T. So using that, first I am finding I. So 96,000 upon 3600, so that will be 80 by 3. Now I am not solving it or bringing it into point, because now the same value I need ahead. Now V equal to IR. So V is given as 50, I is 80 upon 3 we got, and R I don't know. So R will be 50 into 3 upon 80. So if I cut the 0, I will have 15 upon 8. Now I know that heat equal to I square R T. So that is 80 upon 3 into 80 upon 3 into R is 15 upon 8 into 3600. So this is coming to 48 and 5 zeros joule. So if I convert it in standard form, it will be 4.8 into 10 raised to 6 joules. Next, question 3 on page 190 says an electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat developed in 30 seconds. So here R is 20 ohm, I is 5 ampere, and T is 30 seconds. So heat generated H will be I R square T. So that will be 5 square into 20 into 30. So if I solve it, it will be 1500 joule. And if I write it in standard form, 1.5 into 10 raised to 3 joule.